real numbers. Here we go.
I can't show them. I go faster.
Numbers. What's a real number? 2. 2 is a real number, yes. What does it mean to be a real number? Come on, y'all. Y'all remember real numbers?
You're not a negative.
Negatives are real numbers. Basically, any number that you have dealt with in the past is a real number. Other than, of course, when you learned about imaginary numbers in Algebra 2. Remember that? Okay. So, most numbers that we talk about are real numbers. Okay. We have whole numbers. We have negative numbers, y'all said. Fractions, decimals, all those types are real numbers. We talked a lot in Algebra 2 about rational, which means we can write it as a fraction. We talked about irrational. Do you remember what irrational is? There is an irrational number posted really big in my room right now. Yes. Why is pi irrational? It goes on forever and ever with what? Lots of things go on forever and ever, but I do. No pattern to it as it repeats. There's no repeating, okay? Like 1/3 is 0.33333333. That goes on forever, but it's a pattern. It's 3's all the way down, right? Pi has no pattern to it, so it's irrational. So no pattern, goes on forever as a decimal. Let's see. We talked about whole numbers. What are integers? Anybody? Nobody? Positive and negative. I hate to say whole numbers because whole numbers are only positive, but positive and negative numbers with no decimal, okay? Now, I'm going to take just a minute and talk to you about interval notation. If you have had me before, you know interval notation very well. If you have not, I don't know if the other Algebra 2 teachers taught interval notation, so this might take just a minute. So stay with me. When we have a number line, everybody knows what a number line is? Okay. We have this number line. In the middle, we'll put 0, 2. Back when you first learned about number lines and how to describe numbers on a number line, you used things like an open or closed circle at a point, and then it went off forever in a certain direction. Do you remember that? Yes? If you can put that phone away for me, I appreciate it. Thank you. All right, so how would you describe this in green? Anything bigger than 1, right? Let's use a variable since this is algebra. Let's say we're describing x. How would you describe that using x? X is greater than 1, right? How does it change if I do that? Put a line, greater than or equal to. What does that mean? That means 1 is included, right? Are we all clear on that? It means we include it. Well, as we progress in math, we describe this a little bit differently. We use a little more sophisticated way of describing than greater than and less than. We use what we call interval notation. Okay? Interval notation uses brackets and parentheses to describe a set of numbers. So it uses, this is a bracket or a parenthesis. And what we do is when, oh, I got two whites on here. When we have a line under, meaning included, that's when we use a bracket. Okay, so less than or equal to or greater than or equal to, we're going to use brackets. And then when we talk about parentheses, that's when there's no line under. And I know this doesn't make a lot of sense now, but it's going to make sense in a minute. One other thing, as you look at this number line, if I go on forever and ever and ever to the right and get bigger and bigger and bigger, how might you describe that in math? Really big. Come on, my algebra 2 kids, y'all know this. What's way over here? Keep going. Infinity. This is positive infinity. Have y'all seen the infinity sign before? You know what that means? So if all the way to the right is infinity, what do you think all the way to the left is? Negative infinity. So what we're going to do is we're going to take, instead of saying x is greater than or equal to 1, we're going to say start at 1, but I need a bracket because it's filled in, it's included, right? Start at 1, I use a comma, and I tell it where to stop. Go all the way to infinity. Infinities always get parentheses because you can't actually be infinity. Does that make sense? All right, let's try one. Let's see if it makes sense. It's starting to come back. I'm not going to put all those numbers on here because that's really not necessary at this point. But just so you see, let's say this is -5 and I have an open dot going to the left. How would you describe that in interval notation? Interval notation, not greater than or less than that. What you think? Negative infinity, because the smallest it can be, you always want to go smallest to biggest. Negative infinity, parenthesis or bracket on the parenthesis? I said on the parenthesis, on the infinity. And then it goes up to what? -5. Bracket or parenthesis? Why? It's not colored in. It doesn't include 5, so it's a parenthesis. Are y'all with me so far? Always smallest first, up to biggest. Okay. Everybody okay on that? One more. Because it's going to get a little bit harder. We're going to build on that just a little bit. Let's say... Describe that in interval notation. Mm-hmm. Good job. Good job. Easy, right? Make it harder? Okay then, Chandler.
No, I'm just saying because I know where you're going.
Can you do one more like that?
Sure.
I know where you're going.
Do some compound. Can y'all's group see from right there? Are y'all okay? I know you might not can. You might want to sit there so you can see if you... I hate for you to have to keep turning around. It's up to you, though. It's up to you. Wherever you're more comfortable. Okay. One more. Give me a number. 5. Interval notation. Parenthesis. Because you always go smallest to biggest. 5. Parenthesis. Kick it up a notch.
Why don't you?
Not too much, just a little bit. Kick it up just a little bit. Give me a number. 7. Give me another one. And 10. Okay.
So, parentheses 7, comma, and 10 bracket.
That's correct. 7. Smallest it can be is 7, right? But it can't actually be 7, so I do a parenthesis. Then it goes up to, but it includes 10, so I need a bracket. Everybody okay? Easy peasy so far? Sometimes we need more than one piece. Sometimes we need to describe a set of numbers that includes some over here and some over here. So to do that, we piece two intervals together. Let's say let's take our same 7 and 10, and instead of it being in the middle, what if it goes off in either direction? You might remember these from way back when as compound inequalities. X is less than 7 or X is greater than or equal to 10. But how might we describe these in interval notation? And I'll give you a hint. When we join intervals, we use a big U for union. It smushes them. You remember it now? It smushes them together, okay? So it says take this piece and together they make the set. So if I want to describe this, am I going too fast? Am I talking too fast? Okay. If I want to describe this set, which is everything left and everything right, how would I do that? Uh-huh. Now I need to join it because it stops. It stops right there, and I need to join it with this piece. So now I'm going to describe that set. Does that make sense to everybody? Yeah. What y'all think? One more? I want to. Let's do it. Ooh, let's make this one interesting. What's special about both of those numbers? Both of them are irrational. If you put square root of 2 on your calculator, it goes on and on forever. Right. Actually, let's even make this one a little bit harder. There you go, Chandler. I was waiting on it.
That's a good one.
It's a good one. I like it. I especially like the points in it.
They're irrational number.
Yes. And then we got 17 just off over there. Looking lonely. I'm going to have to break my spinner out at some point. My spinner. Call on people. You think you got it? So when you get confused, think about what's the absolute smallest it can be. Negative square root of 2. Can it actually be negative square root of 2? No. So that means I need a parenthesis. Then it goes up until it hits what? Pi. Can it be pi? Yes, it can be pi. It can be pi because there's a dot on pi. Yeah. Now, it skips some space. So to this, I need to join another piece. How do I do that? A U. Now what? Y'all got it. 17 up to y'all got it? Can you do it on your own? Good with that? This is as far, well, you know, interval notation, this is just, we use this to describe domain and range. That's our biggest thing in sets of numbers. So just so that you can understand the way it works is all you need. Let's see. Talk about some certain types of intervals so that you understand. When we have things like, it doesn't really matter what this number is. We'll say 5. When it goes on, actually, whenever it's included here, okay? Whenever it is included here. Whenever it's included, so whenever I have a bracket like this, okay? This is what we call, oh, I didn't finish. Come on. This is what we call a closed interval. And it can go to the left or to the right, but because it's inclusive, because it includes that number, it's closed. So whether it goes that way or this way, those are both closed. Does that make sense? So what do you think it might be called if this were like that? Open. That's an open interval. Again, it can be less than or greater than. It doesn't matter. If it includes it, it's closed. If it does not include it, it's open. Make sense? Easy peasy? Okay. What if, I'm going to trick you now. You ready? I'm not even going to put numbers on it. Open or closed? Let's closed, because these are really included dots, right? What about this? Open? It's called half open is what it's called. It's called half open, actually. So you're absolutely right. Half open. All right, everybody okay? All right, moving right along. This is a lot. A lot of this is going to, I don't want to insult your intelligence, but this is a lot of background stuff we're getting ready to do, okay? What do we call a letter that takes the place of a value? A variable. We use them a lot in algebra, right? What's our favorite variable? X. X is our favorite. What's a constant? So variable takes the place of a value. Constant, you said it always stays the same, and that's right. It doesn't have any variable to it. It never varies in value. It's always the same value, okay? Numbers are constants. When we start talking about equations, the numbers without the variables are the constants, okay? Always. I forget not to write in cursive. Sorry. I'll stop. Oh, here we go. What do you call? So sometimes I have, and I'm going to put a heading here, so skip a little bit of space. How might I expand that? Starts with a D. It's everybody's distribute. When I distribute through, I get 2x plus what? xy. If I started here, and did this, what is that called? The backwards of distributing, or the backwards of multiplying, what is that called? It's a very simple form of it, but it starts with an F. It's the basis of Algebra 2.
I know what you're talking about.
Algebra 2, you did a lot of factoring, okay? You mainly took quadratics and you broke them into two binomials, right? Hopefully everyone in here can do that. We're definitely going to spend a day reviewing that. This is a basic form of factoring where we just pull a GCF out to start with. When you go from the left from the right to the left, right? So this is a basic form of factoring. So X is a factor of those two terms. Yes? Y'all remember that? Are y'all bored or you don't remember it? Y'all are kind of looking like, okay. So this is what we call factored form on the left, right? And expanded form on the right. To expand, we multiply. To factor, we're looking for GCFs to divide out. This lesson is like here, there, and yonder. Now I want you to think back. I think this was chapter 2 in Algebra 2. We talked a lot about what's an exponent? Up at the top, number up at the top. It's a power. It tells you how many times to multiply that base through, right? We talked about 7 main properties of exponents in Algebra 2. Okay, we talked about what to do if you were multiplying with the same base. What do you do with those exponents? You add them together, that's right. What if you had a power raised to another power? Multiply them, that's correct. Let's see, what if I was dividing? Subtract. Y'all do remember these. What happens if I have a negative exponent? You gotta flip it. You're gonna put it over 1. That's exactly right. You're gonna do 1 over, and then you're gonna make it positive. What if it's 0? What if the exponent is 0? It's 1. It's always 1. That's right. Good job, y'all. Excellent job. What if you are... What if you are multiplying inside parentheses and you got an exponent on the outside? It goes to both of them. What if you're dividing inside parentheses and there's an exponent on the outside? What you gotta do? It goes to both of them. Multiplying or dividing, it distributes. Last one. What if you're adding inside? Does it? If you are adding inside there, this was a trick when I put this is not a property of exponents. I put this up there to trick you. If you're adding inside, you can't distribute. What you have to do, you have to write it twice and then FOIL it out. So be careful. Be very, very careful. And very last thing. Everybody's favorite. Scientific notation. So scientific notation, does anybody know what it means? Oh, yes, you do. 1 digit. A decimal. Everything else, yep, times 10. And then this number tells you how many times to move the decimal. I feel like we just did like chapters 1 and 2 in Algebra 2, like that. All right, how many times to move the decimal? Minus the quadratics, of course.
We haven't got anything like that.
We will do polynomials, trig functions, some fun stuff.
Stuff that we didn't get to know.
But we'll still work a lot with quadratics too. A lot of function shifting and transformations. All right, so if it's positive, what do we do? That's right. If it's negative, to the left, to the left. So what would this number be if I had to write this out? Clearly 5 is my favorite number today. I feel like I've used that for everything. So it's 5, 3, 5. How many zeros do I need? 3. Right? So that's the easy part, and that's the part that's assumed you know. The real stuff that you learned to work with in Algebra 2 was whenever we did operations with scientific notation. So maybe I took, am I going too fast, y'all?
No.
Okay. Maybe Chandler's speaking for y'all. Y'all good?
No one else is speaking.
All right. So maybe I have my 5.35 times 10 to the 5th, and I want to multiply 2.73 times 10 to the negative 12. Do you remember what you do? That's exactly right. So I'm going to take the numbers in front first, and I'm going to multiply those. Somebody with a calculator, tell me what you get. Somebody knows. Come on. Somebody. Well, somebody's got a calculator. Oh, dear Lord.
It's 14.
14 what?
14.
5.35 times 2.73? 14 point what? And then we look at the tens, and because they're like bases, what do we do with the exponents? Add them. 5 plus negative 12 is negative 7. Now this is a problem. Why is this a problem? Exactly. This first number, it's only one digit, right? It can't be above 10. So I need to move that decimal which way? Left. Here's where it gets confusing. When you start adjusting, if you need to adjust left, then you add to the exponent. Okay? Most time you see a positive exponent, you move to the right. Well, here, but if I'm adjusting, I have to do the opposite. So if I need the decimal to go left, I add. If I need it to go right, guess what I do? Subtract. So I need to go left 1, which means I'm going to add 1 here. So 1.4605. Everybody okay? What if you were dividing? Subtract. Same exact thing, but I would subtract the exponents instead. All right, y'all.
Just copy.